This test is for integral technique, including constant law, power law, and exponential law, logarithm law, and some of the trigonometry laws. Before we go to the problems, let's quickly go over the rules you need to know for this test. So if you have any constant, then it'll be just that constant x plus c. If you don't have anything, that means one is hidden. So that is just x plus c. And next one is a power law, general power law. And 1 over x dx is ln x. You're not supposed to use a power law for this. So remember this. And integral sine x is negative cosine x. And integral cosine x is sine x. And secant square x, tangent x. Cosecant square x, negative cotangent x. Secant tangent is a secant x. And things like that. And next one, definitely you need to know those rules for inverse sine and cosine and tangent. So let's just start from here. So number one, this one is hidden, 1 dr. So when you take antiderivative, that's in terms of r, so r plus c, or in this case, k and c, those are all constant that represent constant. So answer has to be D. Number two, you can distribute that integral. So integral sine x dx plus integral square root x, you can change it to x to 1/2 dx. So that becomes integral sine is a negative cosine x plus x to 1/2. Use power law. So you add 1, 3/2. So 1 over 3/2 x to 3/2 plus c. That becomes negative cosine x. 1 over 3/2 is 2/3 x to 3/2 plus c. So answer has to be D. Number three. So that's general power law. So 1 over 6 plus 1 x to 6 plus 1 plus c. So answer has to be A. This one just constant, right? So integral 12 dv, that becomes just 12v plus any constant, or you can say k. So answer has to be E. Number five. So integral x to negative 2 dx, you change into power and use power law. So that becomes 1 over negative 2 plus 1 x to negative 2 plus 1 plus c. So that becomes 1 over negative 1 is a negative 1. So negative x to negative 1 plus c, or other format, x to negative 1 is 1 over x plus c. So answer has to be B. This one you can do two ways, but looks like a u sub will be best way to approach this. So let's say u equals 3s plus 4. So when you take a derivative both side, du equals 3ds. So that equation change it to integral u square. So instead of ds, 1 over 3 du equals ds. So that's 1/3 and du. Now, so using power law, 1/3 times 1 over 3 u cubed plus c. Now that becomes 1 over 9 u cubed plus c, and 1 over 9 u substitute back 3s plus 4 cube plus c. So if you look at the answer choices, should it be C? Okay, let's move on. Next one. So this is another typical example of U sub. So let's say U equals 3x minus 1. So when you take a derivative both sides, du equals 3dx. So that becomes, the equation becomes integral e to the u. From here, when you isolate dx, 1/3 du equals dx. So 1/3, you take it out, du. So using the exponential rule, 1/3 integral e to the u is just e to the u, and plus c or k, and then you substitute back. E to the u was a 3x minus 1 plus k. So answer has to be D. Let's move on. Number 8. So this one is another u sub. U equals 2x. So when you take a derivative, du equals 2dx. So 1/2 du becomes just dx. So that given equation, change it to integral sine u instead of dx 1/2. You can take it out. Any constant you can take it out in front of integral. Then du. So integral sine u, that's a negative cosine. So negative 1/2 cosine u plus c, and substitute back 1/2 cosine 2x plus c. So answer choice is B. Number 9. This one you can change it to, you can switch it to using double angle formula. So sine 2x, let's quickly go over double angle formula. 2 sine x cosine x. That's the formula you need to know. So reverse. So integral 2 sine x cosine x, that becomes a sine 2x dx. So now let's say let u equals 2x. So du equals 2 dx. That means 1/2 du dx. So that transfer to integral sine u, and instead of dx 1/2 du. Integral sign is negative cosine, so negative 1/2 cosine u plus c. Now you substitute back. U was 2x, so negative 1/2 cosine 2x plus c. That should be fine answer. So answer has to be C. Now this one is application problem. Number 10. A particle's acceleration along a straight line is given by the formula a of t equals 3 plus 2t for any time t, and which of these gives the correct function for the velocity. So we know your velocity is integrate a of t, right? dt. So just integration of that given function. So integral 3 plus 2t dt. So when you take integral individually, 3 is a 3t plus 2t becomes t squared and plus c. So for answer, A will be right answer. Now free response. Number 11. This is a formula. So basically, that one is just a secant x plus c. Derivative secant is a secant tangent, so reverse integral secant x tangent x should be just secant x plus c. Make sure you put it plus c, otherwise you get partial credit on the test. And this one, let's say u sub u equals g of x. Then when you take a derivative both side, du equals g prime of x dx. So this one change into du, and this one is u cube. So that becomes integral u cube du. So when you do power law, 1/4 u to the fourth power plus c, and 1/4 u was a g of x, so g of x to the fourth power plus c. So that should be final answer. Next one, number 13. You can use also u sub. Let's say u equals denominator 5x squared plus 4. So when you take a derivative both side, du equals 10x dx. So when you isolate x dx, 1/10 du becomes x dx. So that equation becomes integral, instead of x dx, 1/10 du, but 1/10 you can take it in the front. So 1/10 integral du over u. So that's one of the formula. You are not supposed to use a power rule this one. This is just ln. So 1/10 ln u plus c, 1/10 ln 5x squared plus 4 guaranteed greater than 0. So you don't need absolute sign, just you can say 5x squared plus 4 and plus c. That should be final answer. And then number 14. Number 14 here. So when you take integral individually, plus 8 and dt. So take integral one by one. So using power law, this one. So 6/4 t to the fourth power minus 4/3 t cube plus 8t plus c. Now last step is to simplify. So 3/2 t to the 4 minus 4/3 t cube plus 8t plus c. That should be final answer. And number 15, let me put it number 15 on the bottom here. Number 15 was integral x e to the x squared. That. So let's use a u sub. That u equals x squared. So when you take a derivative both side, du equals 2x dx. And when you divide by 2, 1/2 du equals x dx. So that equation changes to integral. 1/2 you can take it out. And e to the u du. Now when you take antiderivative integral, so 1/2 e to the u plus c, and then you plug back in 1/2 e to the u was x squared plus c. So that should be final answer. Now next one, number 16, cosecant squared 3v dv. Integral So this one also u is inside the parentheses, so 3v. So let u equals 3v. So du equals 3dv. That becomes 1/3 du equals dv. So that equation, change it to integral cosecant square u instead of dv, 1/3 du. So 1/3 you can take it out, du. Cosecant square u, if you think about the formula, 1/3 negative cotangent. So cotangent u plus c. Because derivative cotangent is a negative cosecant square. Now you substitute back, negative 1/3 cotangent, u was a 3v plus c. So that's fine answer. And then let's move on. Let me open another page here. Number 17. Root cosine x, sine x dx. Also, I'm going to apply u sub. So let u equals, of course, inside the square root, that is u. So u is cosine x. So when you take a derivative, du equals cosine derivative negative sine x dx. So this one will change it to integral square root u. Sine x dx is a negative du. And negative integral square root change into 1/2 power. Now you can apply power rule. So 1/2 plus 1 is a 3/2. So negative 2/3, because you flip it over, u to the 3/2 and plus c. And substitute back, negative 2/3, u was a cosine x. So cosine x, 3/2 and plus c. So that's fine answer. Number 18. Integral x squared minus 3 squared dx. This one probably you think use a u sub, u equals x squared minus 3. But the problem is when you take a derivative, there's no x dx. So technically we cannot use u sub. So what I'm gonna do, expand it out. So FOIL this expression. So x to the 4 minus 6x squared plus 9 dx. Now you take integral individually. So 1/5 x to the 5th minus 6/3, which is 2x cubed plus 9x plus c. So that will be fine answer. Number 19. Integral cosine x and times cosine of sine x dx. So this one u sub. So let u equals this one here, sine x. Then when you take a derivative both side, du equals, derivative sign is cosine x, so cosine x dx. So that becomes, so equation becomes integral cosine x dx is du. So this one is du. So cosine u, this is u, cosine u du. Now integral cosine is a sine, so sine u plus c, and u was a sine x, so sine of sine x plus c. So that's fine answer. Next one, number 20. Evaluate integral x minus 2 x squared minus 4x plus 7 to the power of 6 dx. This one, I'm going to use u sub. So let u equals the inside the parentheses on the denominator. X squared minus 4x plus 7. So when you take a derivative, du equals 2x minus 4 dx. And I notice x minus 2 dx is on the top here. So you can change into 1/2 du equals x minus 2 dx. So that expression change it to integral. 1/2 you can take it out. 1/2 numerator du. Denominator is u, so u to the 6th power. So that becomes 1/2 integral u to the negative 6 du. So power of 1/2. 1 over negative 6 plus 1 is 1 over negative 5, u to the negative 5 plus c. So run out of space. I'm going to put it here. So negative 1 over 10 u was x squared minus 4x plus 7 and negative 5 plus c. You can put this one on the denominator. So very last step, negative 1 over 10 x squared minus 4x plus 7 fifth power plus c. Then that's going to be your final answer. There's extra credit. Let's do that. Integral sine 4x and secant to the eighth power 4x dx. So let's use u sub. U equals, of course, 4x. So du equals 4 dx. So this expression changed by sine u times secant eighth power u. Instead of dx, 1 over 4, you can take it out, du. Next step, 1 over 4, you can change the secant. Secant u is a cosine, 1 over cosine u, so sine u cosine eighth power u du. Because secant is 1 over cosine. And then one more u sub. So let's say v equals cosine u. Okay. So basically u sub twice. dv equals negative sine u du. So this expression will change by negative 1 over 4 integral. So sine u du, it will be negative dv. So this is dv over v to the eighth power. So that change it to negative 1 over 4 v to the negative 8 dv. Change it to power. Now just use the power rule. So negative 1 over 4 1 over negative 8 plus 1 v to the negative 8 plus 1 plus c. So negative 8 plus 1 is negative 7. So 1 over 28 v to the negative 7 plus c 1 over 28. V was a cosine u. So that becomes 1 over 28, 1 over cosine 7 power u plus c. And then we know 1 over cosine is secant, so 1 over 28 secant to the 7 power u plus c. And u was, if you go back here, was a 4x. So substitute back, that's the last step. 1 over 28 secant to the 7 power 4x plus c. Double check, yes.